Okay, so picture this. You're an architect, but you're not building with steel and glass, you're building with data. Giant, organized warehouses of pure information. But once it's all built, how do you actually talk to it? How do you find anything? Well, that's exactly what we're going to get into.
And that really is the core problem, right? You've got millions, maybe billions, of records just locked away inside a database. You need some way to communicate with it, to ask it questions, tell it what to do. You need a language.
And that language? It's SQL. Seriously, think of it like the universal translator for pretty much every major database system on the planet. It's how we turn all that raw data into actual, useful decisions. It's the official toolkit for our data architect.
So here's our plan for this explainer. We're going to go on a little journey. First, we'll draft the blueprint for our data structure. Then, we'll stock the shelves with the actual data. After that, we'll learn how to ask it smart questions, connect different data warehouses together, and finally, we'll break out the real power tools. Sound good? Let's dive in.
All right, first things first. Before you can put any data anywhere, you have to build the container for it, right? You need the structure. This is the blueprint phase, where we lay the foundation and build the frame. And to do that, we use something called Data Definition Language, or just DDL for short. And the difference here is actually super simple if you think about it like this. DDL is all about building the house. Commands like create and alter. DML, on the other hand, is about putting the furniture inside the house. That's your insert and update commands. I mean, it makes sense, right? You can't exactly put a couch in a living room that you haven't built yet.
Okay, now let's talk about getting rid of stuff. There are three main ways to do it, and they are very different. First, you've got drop. Think of this as the wrecking ball. It completely demolishes the structure and everything inside it. Poof, gone forever. Then there's truncate. This is more like instantly emptying out the entire warehouse. It's super fast, but the building itself is still standing. And finally, you have delete. This one's way more careful. It goes row by row, which means you can be really specific using a where clause. And trust me, if you're taking any kind of exam, you absolutely have to know the difference between these three.
All right, so our warehouse is built. The structure is solid. Now it's time to actually stock the shelves, bring in the goods and fill our tables with useful information. And this is where we switch gears from DDL over to DML.
And really, stocking those shelves just comes down to three main actions. You insert new inventory when it arrives, you update the records for stuff you already have, and you delete items that you don't need anymore. It's that simple. Insert, update, delete. These three are the absolute workhorses of day-to-day data management.
So, what's the point of having a massive warehouse full of data if you can't find anything? It's totally useless. The real power of SQL, the magic, comes from asking questions, from querying all that data to pull out actual insights. This is the part where we turn raw data into real knowledge.
Think about it. Instead of manually sifting through thousands of student records one by one, what if you could just ask the database a simple question, like, hey, what's the single highest GPA you've got? And boom, it instantly shoots back the answer, 4.00. That is the power of an aggregate function like max.
And there are 5 of these core functions that are basically your go-to tools for summarizing data. They can take a whole column of numbers and just boil it all down to one single meaningful result. What's the lowest score? The total sales, the average rating, or even just how many students are in this class? These aggregate functions, they give you the answers.
Okay, let's tackle a classic, and I mean classic, interview question. What's the difference between where and having? Here's the best way to think about it. Where is like the bouncer at the door of a club. He checks everybody's ID one by one before they're allowed to go inside and form groups. Having, on the other hand, is like the club manager who walks around after everyone's already grouped up and asks, hey, is your group bigger than 10 people? See the difference? Where filters the individuals. Having filters the groups.
So far, everything we've done has been inside a single warehouse. But in the real world, that's rarely how it works. Your data is usually split up across a bunch of different specialized buildings that are all related. So to get the full picture, you've got to connect them. And that, my friends, is where joins come in.
Just as an example, imagine you have one table with all your student info, names, student IDs, that kind of thing. And then you have a totally separate table with just exam results, student ID and their score. So, how do you connect a student's name to their score?
Well, the most common way is with an inner join. What it does is it looks at both tables and only shows you the records that have a match in both places.
It's basically finding the overlap, the intersection. So what you get is a perfect list of only the students who actually took an exam, with their names right next to their scores.
But what if you want a list of all the students, even the ones who didn't take the exam? What then? Well, that's exactly what a left join is for. It grabs everything from that first or left table, in our case, all the students, and then it tries to find a matching exam score. If it can't find a match, no problem. It just leaves that score column blank, or what we call null.
So here's a quick cheat sheet to keep it all straight. Inner join just gives you that matching overlap. Left and right joins give you everything from one side plus the overlap. And a full join, that gives you literally everything from both tables, matched up wherever it can. So here's the key takeaway, the one question to always ask yourself. Do I need to see records even if they don't have a match? If the answer is yes, you're looking at a left, right, or full join. If the answer is no, then inner join is the tool for the job.
Okay, we've covered a ton of the essentials. The blueprints, stocking the shelves, asking questions, and connecting the dots. But this toolkit has some serious power tools for when the jobs get really complex.
And these are total game changers, I'm not kidding. You've got things like window functions, which let you do cool stuff like rank students within each department. Then there are recursive CTEs. I know, they sound complicated, but they're perfect for navigating things like a company org chart. And you've also got views and stored procedures, which are just fantastic time savers. They let you wrap up a bunch of complex logic into a neat little package so you or anyone on your team can reuse it with a single, simple command.
So with all this information, where should you focus your energy? Well, if you're studying for a test, this breakdown is golden. A whopping 30% of questions are probably going to be about joins. Another 20% on grouping and aggregates. You add that up, that's half the exam right there. So mastering these core concepts is absolutely your most direct path to acing it.
And this might be the single most important piece of advice I can give you. Don't just memorize the code for a left join. You have to understand why you would need it in the first place. Why would you pick truncate instead of delete? Once you really get the why, the how, the code just follows naturally.
So there you have it. We've gone from a completely blank slate to a fully equipped data architect. You've got the toolkit. You know how to build the structures, manage all the information inside, and pull out some seriously powerful insights. So the only question left is, what are you going to build first?